Hey guys, welcome back to Sports Betting Truth, and today is the debut of the highly anticipated series I'm going to be doing on this channel, How to Analyze Sports with R. Now, I just want to point out that this series isn't exactly going to tell you how to build a sports model in R, but it's going to teach you the concepts and basics of R to get you started. But before I begin, I just want to point out that this video is sponsored by our friends at BetRivers and BetMGM. These are two stateside facing sportsbooks that you can sign up and deposit to in an app and bet stateside without having to send your money overseas and take a big risk. I don't know about you guys, but I wouldn't trust sending my hard-earned money overseas to sportsbooks that are unregulated and who knows where they're located, what they do, what happens if you get in a dispute. Just keep your money here in the United States, bet legally, bet stateside so you can have that peace of mind. Now, if you live in Pennsylvania or Illinois, BetRiver is giving you an instant $250 deposit match on any deposit when you sign up with the link below in the description. And if you live in Tennessee, Colorado, Indiana, or Iowa, use the link below in the description to get an instant $500 deposit match on your deposit with a minimum of $10 deposit. So once again, Pennsylvania and Illinois, you can get up to a $250 instant deposit match if you sign up at the BetRivers Sportsbook with the link below. In Tennessee, Colorado, Indiana, or Iowa, you can get up to a $500 instant deposit match by signing up with the link below in the description. Now R is a powerful scripting programming language that you can use for a lot of things, but it's mainly for statistics, and it's what I mainly use, not just for my sports betting, but also in my career as well. Now, R has a lot of benefits over something like Excel. Now, Excel has its value. I think Excel can do a lot of great things, but where R has an advantage over Excel is that it's a lot faster, and you can work with objects known as data frames that are very powerful that you can't really do in Excel as easily. Now, those are the two main advantages over Excel, with the third advantage being it's free. R doesn't cost any money, while Excel, you have to pay a subscription for it. So I think if you can learn how to use R, it's a no-brainer. And that's what this video series is for. I'm going to teach you the basics of R. Now, this video is made with people with zero programming experience in mind, so it's going to be pretty low level. So if you do have programming experience, be patient. Things will come to you in a bit. I also want to point out, like I said, this series is not teaching you how to build a model. This video is teaching you concepts and the basics of R. So one thing I advise you please not to do is flood the comments section of these videos with, hey, I've run into a problem, help me out. I will not answer them. I'm going to say that right now. I will not answer those. That's always been the biggest pet peeve of mine when it comes to all my videos and how-to series and tutorials is too many people are flooding the comment section with problems. The best way to learn this stuff by far is to troubleshoot yourself, learn from your own mistakes, learn how to solve problems yourself without having to run and ask questions. You can Google all these problems. I guarantee you're going to find answers. Troubleshoot yourself. I'm not here to do this for you. I'm not here to hold your hand all the way through. I'm teaching you concepts, and it's up to you to digest that and learn how to use it yourself and install that within your knowledge. And that's the only time I'm going to say this. So if you're asking for help on something, you're running into problems, running to an error, and you're like, hey, I'm getting an error. How do I fix this? I've already warned you. I'm not going to answer it, so don't take it personally. So let's get started. So the first thing we want to do is we want to install R and RStudio. Now, they're two separate products. Think of R as like the overall package, and RStudio is kind of like a graphical interface that you can use to interact with R, but you need to download both. I'm not going to show you how to do that. You guys know how to use Google. Just Google R and RStudio, download them both, install them, all that, and once you're ready, open up RStudio, and it's going to look blank like this. Now, your colors might be the same. You can change the colors. The default's going to be white, but I have it as a dark blue just so it's a little bit easier on the eyes. But what we're going to do is when we open RStudio, the first thing we're going to want to do is set a directory. So save the untitled as whatever you want to call it. I'm going to call it learnr.r. Don't forget the .r when you're saving it. So go ahead and click save, and wherever you save that file is going to be your working directory. So keep that in mind. Make it easily accessible and rememberable. So once you are all ready to go and you have a blank RStudio ready to go, we're going to do this. We're going to run our first command, and it's going to be library. Now, libraries are various packages that come in R that you can use to do a lot of things. Pretty much libraries are like libraries of pre-written code and functions that you can use for your own benefit. And so the first library we're going to load is the readr package. So go ahead and select all this after you type that in, library readr. To run code in RStudio, you have to select everything and then click run. That's how you do it. So if you don't select it, it's not going to run, because basically selecting and then clicking run will compile it all. So go ahead and do that, and we're going to load the readr package. It'll say loaded. If it doesn't work for you, you're going to have to install it, because I guarantee you if you're just starting out, then you haven't installed it yet. You're probably going to get an error. So in order to install a package, you come down here to the console and click install.packages readr. Since I already have it installed, I'm not going to redo it, so I'm going to click cancel. But if you don't have it, it's going to install, and when it's done, then you can come back here to library readr and click run. So why am I asking you to do this first before we do anything else? Well, the data set we're going to use for the series is a CSV file, and the readr package has a function called readCSV that reads CSV files. That's how you can import CSV files into R to use. So where are we going to get this file? We're going to go to my website, sportsbettingtruth.com/learnr.csv. So go there, and it's going to download. You're going to get to learn R CSV. Go ahead and open it. And what this CSV file is, it's a data frame of 2018 college basketball statistics, right? So 2018 college basketball statistics, this is going to be what we're going to use. This is our data set for the series to help you learn how to use R. So go ahead and save that in the same folder where that learnr.r file is. So remember, I have mine right here in the CBB folder. Here's my, well, if you select all files, then you'll see the R package. But whatever the folder that your learnr.r file is, go ahead and save this learnr.csv file too. Since I already have it there, yes. All right, and now we can begin. So our first command we're going to run is readCSV learnr.r, and make sure it's in quotes. You're going to have to do that a lot. Get in the habit of putting things in quotes unless it's a number or a variable. We'll get to that later. But when you click run, if you did it right, if you've loaded the packages right and everything up to this point, whoops, I accidentally did learnr.r, it's learnr.csv. Everybody makes mistakes. Okay, so it just read this frame, right? And so you're like, okay, now what? Well, we're going to come back to that. But before we get back to that data frame, go ahead and click this broom to clear the console, and we're going to do some basic math. We're going to learn basic math in R, right? So go ahead and type 3 plus 5, and then click run. 8. Go ahead and do 6 minus 4. Run. 2. Then 9 times 9, run, 81. 20 divided by 5, run, 4. And then 5, 2, run, 25. So this is basic math in R. It's not too complicated. The plus obviously adds, the minus subtracts, the asterisk multiplies, the slash divides, and the caret is an exponent. There's also math functions we can use. Let's try this one. SQRT, 81, square root. What do you think it's going to be? 9. So that's how you can do some basic math in R. Pretty basic, right? And now we're going to do the first variable. Now a variable, for those of you who don't know, is basically a name that you use to designate something, right? So if I do this, my first variable, right? And the way you assign variables in R is the little arrow pointing to the left and hyphen. So like you're doing a little arrow. Most languages it's equals, but in this language it's arrow. So my first variable equals 2. So if I go ahead and do this, my first variable, and run these 2 lines of code, it's going to output 2 because I assigned the number 2 to my first variable. What if I do this? My first variable equals 2 plus 5. Now what? If If I run these 2 lines of code, 7, because I assigned 2 plus 5 to my first variable. So you store data in variables. That's what variables are. It's how you store things in R. Very important. Very, very important. So what if I did my first variable equals 3 plus 5 times 6? Well, it's going to be 8 times 6, 48. So that's how you do variables in R. Now, in order to notate in R, so say I do this. Assign variable, output variable. So I'm typing things prefixed by the score sign. It's going to ignore that. So if you want to notate things and not have it actually run code, put a score in front of it, and that way you can make notations in your code, explain things, and all of that. So what if I do this? My variable 1 equals 4, and then my variable 2 equals 6. So what if I do my variable 1 plus my variable 2? What do you think is going to happen? 10. It added my variable 1 plus my variable 2. What if I did my variable 1 times my variable 2? What do you think is going to happen? 24. You can multiply, divide, you can do whatever you want with your variables. That's what they are. They're just stored data. And if you want to multiply, add, subtract, divide, put them in a function, whatever you want to do, that's what variables are for. You assign things to them. Now I'm going to go through the print and paste functions real quick. So these are going to be our first functions. So a function is pretty much a code that you input something into. So remember the square root we did earlier? Actually, that was our first function. Square root 81, that's a function. It returns the square root of the input, which is 81, which is 9. So our second function is going to be print. This is usually the first function you learn in various programming languages, but this is going to be our second. But print sports betting truth is awesome. Obviously, we all know what's going to happen. There we go. Not too complicated, so I'm not going to spend much more time on it. But what if we wanted to do this? What if we have paste variable 1 equals hello, and then paste variable 2 equals 16, and then paste variable 3 equals Sherwood, right? So hello 16 Sherwood. What if we wanted to print all those at once? Well, what if we did this? Print paste variable 1, paste variable 2, paste variable 3. What do you think is going to happen? Uh-oh, we got an error. Too many values in there. So you can only print one object at a time. So if you want to do more than one, you have to use the paste function. So paste. Now we separate our variables by commas, and then you select a separator. Now, by default, the separator is a space, but say we wanted to separate these by a hyphen. So sep equals quotation marks hyphen. Remember, quotation marks are very important. You got to use them when you're using a string. And I'll get more into what a string is in a bit. So now what happens? Okay, now all of them got printed, separated by a hyphen. Hello 16 Sherwood, like that. So that's how you're able to output multiple objects in a print. And you can wrap that in a print function as well. It'll be the same thing, but there we go. All right, moving on. So I'm going to go into data types real quick because I just brought up string, and you're probably wondering what's a string. Well, in R, for the most part, there's 3 main data types. You got your strings, which are text. So variable string equals hello. So if hello is text, that's a string. And then you have numerics, obviously, variable numeric 1, or it could be a decimal, whatever you want. Anything numeric is going to be numeric. And then you have logical. Variable logical equals true or false. So logical is pretty much true or false. Those are the 3 main data types in R, and mainly the only 3 I really use. There's also other data types like factors that we'll get into a bit, but for the most part, those are going to be your main 3 data types. So anytime you're working with a string, you have to wrap it in quotes. If you're working with numeric or logical, you don't have to. It'll be able to determine the difference. But those are our 3 main data types. So now we're going to move from data types to data structure types. This is very important. This is how data is structured within R. And each one I'm about to talk about gets a little bit more advanced. So the simplest data type in R is obviously what we've been doing, a single variable. So single variable equals 3. So when we call single variable 3, it's a variable that has one data point in it, which is the number 3. But what if we wanted to do more than one? So what if we do this 3, 5, and then try to assign that to single variable? Can't do that because you can only assign one data type. So that brings us to our first data structure type, which is a vector. A vector is a one-dimensional, list of values of a single data type. So say I did this, our first vector. Now to create a vector, and this isn't just for vectors, but you need to know this for a lot of R, use the function C. So C pretty much says assign everything within these parentheses into our variable. So what if I did 1, 2, 3, 4, 5, and then ran our first vector? Our first vector. Okay, it prints out 1, 2, 3, 4, 5. That is our vector right there. A list of 5 numbers. Now what if I wanted to do this? Our first vector, 1, and then I want to put a string in there, hello, and then a logical, and then the number 2. What if I did that? Well, it kind of worked, but the thing is, it converted everything to a string because a vector can only handle one data type. So it can only handle numerics or logicals or strings, but only one. So because there was a string in there, it coerced everything else into a string. That's not what we want. So vectors only work best when you're using the same type of data, whether it be numeric, string, or whatever. Otherwise, if there's a string in there, it's going to coerce everything into a string, and that's not what you want, trust me. So that is how you create vectors. Whatever you want to put in the vector, you use the letter C and wrap it around. So what about this? Our second vector equals C, true, false, true, false, true. Okay, what happens with this? Our second vector. Well, it's a vector of logicals. And within that, okay, you're like, okay, how can I use this? Well, now let's get into some functions. The sum function. What if I did sum our second vector? What do you think is going to happen? 3. You know why it's 3? Because with logicals, true equals 1 and false equals 0. Since there's 3 trues in here, we got the number 3. What if we did this? Mean our second vector. 0.6. Remember? 3 trues, 2 falses. The average of that is 0.6. Let's do this. Our third vector equals C, 5, 10, 15, 20, 25. Let's do that again. Sum our third vector, 75. That's the sum of everything in the vector. Mean our third vector, 15. 75 divided by 5. Square root our third vector. It returned the square root of each of the numbers in there. Pretty cool, right? So when you apply a mathematical function to a vector, it will assign that function to every part in the vector, something like square root, but sum and mean is going to take everything in there. So it's a little bit different. So let's do this. Combo vector 1 equals C, 1, 2, 3, 4, 5, and then combo vector 2 equals C, 1, 2, 3, 4, 5. So what if we did this? So let's go ahead and run those. What if we did combo vector 1 plus combo vector 2? What do you think is going to happen? We got 2, 4, 6, 8, 10 because it added the numbers in the corresponding indexes together and returned a single calculation. You can do that, or you can do times combo vector. You can do divided by combo vector. All ones because it's divided by the same numbers. Pretty nifty, right? So what if you did this? What if you changed this to only have 3 values? So what would happen then? What do you think is going to happen? So what if we did that and then did combo vector 1 plus combo vector 2? One has 5, one has 3. What do you think is going to happen? Well, it's not going to work because it has to be identical, right? But what if you tried to multiply instead of add? Same thing. But what if you did this? What if you did combo vector 2 plus combo vector 1. Oh, not going to work either, right? So what if you did this? What if you changed this to just one value? Is it going to work then? Combo vector 1 plus combo vector 2. Yep, it did. You know why? Because you can't, it does work with just one number because it's just going to add that to every value in combo vector 1. Same with multiplying. See, it multiplied everything by that number. So it will work with one number, but if it's more than one and uneven, it's not going to work. So it either has to match the number or it has to be 1 in order to use math between the vectors. So to select a part of the vector, you use the index. So in any type of data structure, when you're trying to get the index, you use brackets. So I'll show you this. Combo vector 1 brackets 3. What do you think is going to happen? Well, return the number 3 because that's the position of combo vector 1. So what if I change this to 9, 8, 7, 6, 5 and ran combo vector 1 again and then did the number 3? What do you think it's going to return? 7, because 7 is in index 3 of the vector. And that's how you select items within the vector. Use the brackets. So those are vectors. Those are the simplest types of data structure that you can use. But what if you wanted to go a little bit further? Well, that's where matrices come into play. Matrix, matrices, however you want to call it. Now, to create a matrix, let's do R first matrix. Use the matrix function, matrix, and then data. So for this case, let's use the number 0. N row, number of rows, let's do 3. And n col, number of columns, equals 3. And that's all we really need for now. So go ahead and run that. And then type R first matrix. Look at that. A 3 by 3 of zeros because that's the data we selected, right? So a matrix is pretty much like a two-dimensional vector. It doesn't just have a row, it also has columns as well. So a matrix, like a vector, can only handle one data type. So it can only handle numerics or strings or logical. It can't handle more than one data type. So say we wanted to add a vector to the matrix. What if we did C1, 2, 3 and then ran the matrix? What do you think our first matrix is going to be? Oh, look at that. 1, 1, 1, 2, 2, 2, 3, 3, 3. Pretty cool, right? What if we did this? Matrix C1 to 9. What do you think is going to happen with the colon in between? Oh, look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So anytime you type C1 and then colon and then a number, it's going to return a sequential list of numbers going from start to finish. So basically start before the colon, finish after the colon. So that's how that works. So with our first matrix, how do you select an item from the matrix? What if we did it like we did the vector? R first, I'm going to do it up here just to make it a little bit easier. R first matrix 2. What if we did it like that? What if we're trying to select the second item? Is it going to work? Well, it kind of did, but what if we wanted to select the number 5, right? That's not going to work. You just use the comma, R first matrix 2, 2, then it's going to select the number 5. So you're selecting an index. The first number is how many rows down you go, and the second number is how many columns over you go. So if we did 3, 1, we're going to get the number 3 because we went down 3 over 1, and that's where this 3 is. That's how you select items within the matrix. What if we did this? What if you wanted to select an entire column? What if we wanted to select the entire second column? Well, how do you do that? Well, remember, you leave the row selection number blank and then 2, and that's how you select the second column. See, it selected 4, 5, 6. You can do the same with rows. What if we wanted to select the third row? Well, you just put the row number you want and then leave the column blank, and that's the entire third row, 3, 6, 9. What if you did this? What if you wanted to select the first 2 rows? 1, 2. Well, there we go. It selected the first 2 rows because we did 1, 2. What if you did 2, 3? Well, it's going to select the last 2 rows. What if you did 1 through 3? Well, it's going to select everything, but you get the idea. What if you wanted to select the first 2 rows and then the third column? Well, 7 and 8. Because when you come back here, 7 and 8 in the first two rows in the third column. What if you did this? What if you did -1? What do you think is going to happen? -1. It omitted the first row. If you put a minus before, then it's going to return the matrix without the number that you put the minus before. So it return it without the first row. What if you did this? C -1 to -2. It only turned the third row because we did C -1 to -2 and got rid of the first two rows. So that's how you select indexes within your matrix. But remember, since it returned only one row, it came back as a vector. You'll need to keep that in mind going forward. All right, so let's do this. Our second matrix equals C, matrix C, 1 to 16, n row equals 4, n col equals 4. So here's our second matrix, pretty much just a bigger square of our first matrix. Our second matrix, pretty self-explanatory, right? You can use the same functions that you use in the vector. So what if you wanted to sum up the entire first column of this matrix? Well, you do sum our second matrix, and then just select the first column. Remember, blank for the how far down you go, and then put 1 for the how far we want to go. And then it's going to sum 1, 2, 3, 4, 10. 1 plus 2 plus 3 plus 4. What if you wanted to sum the entire first row? 28, because that's 1 plus 5 plus 9 plus 13. What if you wanted to get the average of the first row? Well, you do mean. 7, that's 28 divided by 4. What if you wanted to get the highest number in the third column? Well, you do max. Leave that blank 3. What do you think it's going to return? Well, it's going to return 12 because that's the max number in column number 3. What if you wanted to get the smallest number? Well, you do min. Same thing, it's going to return the number 9. There you go. What if you wanted to get the number of rows in our matrix? Well, n row, our second matrix. That's how you do it. It's going to return the number 4 because there's 4 rows in our matrix. What if you did this? Our second matrix, 1 to 2. What do you think is going to happen? 2, because we only selected the first 2 rows. What if we wanted to get the number of columns? Well, it's self-explanatory, n-col, n-c-o-l, our second matrix. Get rid of the indexing. 4, because there's 4 columns. So that's kind of how you manipulate matrices to get the number of rows, columns, sums, all of that. You can do a lot with matrices. But the limitation of matrices, as I said, is that you can only store one type of data in there. Numeric, logical, string. What if you wanted to have like a matrix, but one column was strings, the other column was numerics, another column was logicals? Well, that's where this comes into play. So remember the read CSV function earlier? Well, let's load that frame up again, and this time assign it to a variable. Let's call it hoops 18, because it was 2018 basketball. Assign that to a variable, read CSV, learn r.csv. So we just assigned to hoops 18 the CSV file that I had you download. So if I do hoops 18, this is what's called a data frame, because this has different types of data. This first column is a number. The second column is a string. We got a logical right here. Did they make the NCAA tournament? True if they did, false if otherwise. So we got various types of data in the data frame, and that's what a data frame is. It's like a matrix, but it supports multiple type of data. So you're probably wondering, well, why would I use a matrix then when I can just use data frames? Well, speed is the reason. Unless you absolutely have to have different types of data in the frame, you want to use matrices because they're a lot faster. That's a big deal when you're, having it. For example, my Monte Carlo model in college basketball or baseball, I convert everything into matrices because it's so much faster and therefore minimize the amount of time it has to process everything. So speed is the reason you want to still use a matrix if you can still use the same types of data in there. But data frames are probably going to be your most used type of data structure because they're just so flexible. And data frames work the exact same as matrices do, whether it be calling an index. So if I did hoops 18 1 1, that's going to return right here 1 1. But it returned what's called a tibble. A tibble is like a table that it returns, because a data frame, unlike a matrix, it's not going to convert directly to a value. So in order to solve that, in order to prevent it from returning as a tibble, you do this. So I'm going to go up here. I'm going to do as.numeric hoops 1811. And this time it's not going to return as a tibble. It's going to return as a number because we coerced it to a number out of the table or the tibble with the as.numeric frame or function. So if you're trying to get things out of tibbles like that, because trust me, it will matter, you do want to get in the habit of doing this. Because there will be times where if you don't coerce it from a tibble to a number, for example, it's going to ruin your code and you're going to get errors and wonder what's going on. So get in the habit of doing this when you're trying to get stuff out of data frames like this, especially a single value. So what if we did this? Hoops 1812. Well, that's going to return Villanova in a tibble. So to coerce that to a string out of the tibble, you do as.character. And then you'll just get Villanova and not the tibble. And then column number 4 is logical of whether or not they made the NCAA tournament. So if we did this, hoops 1814, we're going to get true in a tibble, so then you do as.logical. And then run that. Then you just get true without the tibble. And so that's how data frames work. Very similar to matrices in terms of calling, like if you did it like this, let's do hoops 18 C1, 3, 5, 7, 9, and then C4 to 6, right? Well, we got the columns 4 through 6, and then row numbers 1, 3, 5, 7, and 9. Just an example. So one thing you can do with data frames that you cannot do with matrices is you can use what's called atomic vectors. Now, an atomic vector is pretty much this. So let's go ahead and display our frame again, hoops 18. So an atomic vector is pretty much this. If I did hoops 18 team name and then ran that, it just listed off all of the team names with the named column because the column is named team name, right? So you can refer to a column in a data frame by its name by using the atomic vector, the $ in between the name of the data set and the column name, right? So if I just wanted to call an index, so team name 1, I just get Villanova because it returns me the first value of the team name column. What if I did this, 1 to 5? There we go, Villanova, Duke, Virginia, Purdue, and Cincinnati. And the benefit of that is that you don't have to do the as.numeric, as.character, all of that, because it doesn't convert it to a tibble, it just returns a vector. If I did as hoops 18 team name C1, 3, I get Villanova and Virginia, numbers 1 through 3 in the hoops 18 frame. So that's what's called an atomic vector. And you can do this. Sum hoops 18 team ID. It's going to return a big number, but you get the idea. You can use atomic vectors for the same thing like that. Pretty cool, huh? But just for data frames. You can only do that for data frames. So to recap, a vector is a one-dimensional list of values of the same data type. A matrix is a two-dimensional grid of values of a single data type, and a data frame is a two-dimensional grid that can contain multiple data types. So I'm going to briefly cover factors. Now, I don't use factors very much. It's just a personal preference for me, but you might like to use factors. So a factor is pretty much how you order and categorize a string, right? You convert something into categorical data. Now, let me explain to you. So if you want to actually view a data frame or a matrix or whatever in R Studio, you can actually use the view with a capital V function and then the data frame. So if I did view hoops 18, it actually lets me view it a lot easier than it would in the console, and I can look over. So going back to factors, a factor is how you order categorical data. Now, you have two types of data. You have continuous numbers and categorical data. So a continuous number would be something like this, offensive efficiency. It's a continuous number. It's not categorical. Meanwhile, the NCAA tournament round that the team reached, that would be considered categorical because it's not a continuous number. It's divided up into various sections, right? So that's the difference between categorical and continuous. So if we were going to coerce this NCAA round column into a factor, we would have to come up with what's called levels. So obviously the championship, the is the highest level there is because you can't get any better than that. And then meanwhile, the first 4 right here, UCLA, that's the first level. So if we wanted to coerce the NCAA round column into a factor, we would do this. Hoops 18 NCAA round equals factor. Hoops 18 NCAA round, comma, and then levels, and we would start with the lowest level to the highest level. So first 4, lowest level, then round to 64, second level, R32, third level, S16, fourth level, E8, fifth level, F4, sixth level, runner-up, seventh level, and then the best level, champ, 8. And then ordered equals true. That means that we want our factor to be ordered by that. So if we ran this, whoops. All right, the reason that's wrong is because I forgot it's levels equals, and then I forgot the C. So remember, everyone makes mistakes. That's why I'm not going to edit that out, because everyone makes mistakes. So levels equals C, where the levels we're doing is a vector, right? A vector of levels. And then we would hit hoops 18 NCAA round. So we just coerce that to a factor. So if we wanted to go forward and be able to like order the categorical level in there, then we could do it like that. And that's what a factor is. You assign various levels a hierarchy of categorical data. And we coerce the NCAA round column of the data frame to do that. But that being said, this is something I haven't covered yet. If you want to change a value in a matrix or a data frame, you just do it like I just did. So let's go back to our matrix. What do we call it? Our second matrix. So if we wanted to change a value, you would just do it like this. You would call the index. So say we wanted to change the value of 3, 3. So the number 11 to 30. So 3, 3, 30, right? Run that. And then what happens when we run our second matrix? Well, number 3, 3 changed to 30 from 11. And that's how you change a value within a data frame or a matrix, just like that. Pretty simple. So what if we wanted to change everything in column 3 to the number 4? Well, we run our second matrix, and now everything in column 3 is 4, right? That's how you do it. So what we did up here with the factor is that we changed everything in the column NCAA round to a factor and assigned the levels of that factor in there. So in order to see if that worked, we're going to do what's called the str function. So str hoops 18, this kind of, I'll explain it when I run it. So run str hoops 18. It pretty much tells you like what type of data each column is. So team ID, numeric, team name character, conference character, NCAA logical, whether or not they made the NCAA tournament, NCAA seed, numerical, and then NCAA round ordered factor with 8 levels. So first 4 is less than R64, less than R32, and so on. So later on, if you're trying to do analysis based on NCAA round, you can categorize that factor in the NCAA round level to create a ranked hierarchy. First 4, worse than round to 64, worse than round 62, and so on. That's what a factor is. More on that later. And then if you want to do summary, hoops 18, this returns a summary of all the values in the data frame. For anything numeric, it's going to give you a min and a max. It's going to tell you how many NAs are in there. It's going to give you a first and third quintile. It's going to give you a median and a mean. So pretty cool way to look at a data frame. But the thing with our hoops 18 data frame, it's so much rows, 351 rows of data. What if you wanted to look at like the top, just the first few just to get an idea without it like running the whole frame? Well, that's where the head function comes in. So if I did head hoops 18, well, it only returns the first 6 rows. Likewise, if I did tail hoops 18, it's going to return the last 6 rows. So that's kind of like an easy way to get a glimpse of just the upper part of the data frame, just to get an idea of what it is. Because there's times you're going to work with data frames or matrices that are really big and really long, and if you just type it in here like that, fortunately it's cutting it off right here, but there'll be times there's so much in there it just floods the whole screen, you can't really get anything out of it. And it's easier just to use head or tail to get a look at it instead. All right, so now we're going to talk about column names and row names. So hoops 18, if I did head hoops 18, you can see what the column names are. Team ID, team name, comp. And you can get this by doing this, call names, hoops 18. It returns a vector of the column names. What if you wanted to change one of the column names? What if we wanted to change the third column from conf to conference? Well, you do it like this. Remember, the column names are a vector, so you change them like you would a vector. So let's create a vector real quick called vector test equals C, 1, 2, 3, 4, 5, right? Vector test. Now remember, since a vector is only one-dimensional, right, they don't use the index column and row like a matrix or data frame. It just uses one number. So if I did vector test 3, well, I get the third item in the vector. So what if I wanted to change the third item to the number 8? Well, I do vector test 3, 8. And then if I do vector test down here, it returns, there's an 8 in there because we changed the third index from 3 to 8. So you change column names just like that, because since the column names are a vector, you change it like you would a vector. So if I wanted to change the third item from comp to conference, I would do call name 3, conference. Remember, it's in quotations because it's a string. So now if I did head hoops 18, it's conference. That's how you change a vector of column names. What if I wanted to change the third and fourth one? I would just do this, 3, 4. And then you got to do C. Remember, it's a vector. You got to wrap it in C. And then if I want to change it back to conf, and then this to an NCAA tourney, and then I run it, and then I do head hoops 18. Look, conf, then NCAA tourney. That's how you change multiple column names right there. What if I wanted to change the third, fourth, and then sixth? Well, just like this. C, 3 to 4, 6. Just like that. And then, I don't know, Horace, just so we can tell it's there. And then head hoops 18. Oh, look, it's Horace, NCAA tourney, comp. That's how you change multiple column names. Column names are pretty common, but less common are row names. You don't really use row names I don't use them that much, but you know, just for the sake of this, let's go back to our second matrix. And let's assign, you can assign row names and column names and matrices as well. So let's do row names, our second matrix. What do you think it's going to return? Null, because there aren't any. So if we wanted to assign them, we could just do this. See, first row, second row, third row, fourth row. You just assign a vector to it, a C vector. And now what happens when we do our second matrix? Well, they have row names now. First row, second row, third row, fourth row. That's how row names work. A little bit less common. I don't use them that much, but you might want to. I don't know. It's a preference thing. So remember how I said the benefit of a matrix is that it's faster? Well, what if you wanted to convert a part of your data frame into a matrix? All right, well, let's do this. Head, hoops 18. So what if we wanted to convert these three columns, O, E, E, F, G, and SR2 into a matrix for use, right? So 1, 2, 3, 4, 5, 6. So it starts at number 7. So let's do this. 3 hoops stats equals hoops 18, 7 to 9. And then when we run 3 hoop stats, here's a tibble of O, E, E, F, G, and SR2, right? But what if we wanted to turn that from a data frame into a matrix? Well, you do this. As.matrix, hoops 18, 7 to 9, and then 3 hoop stats. Now it's a matrix. And the benefit being, you're going to be able to use it, and it's a lot faster than a data frame. Like, very important if you're looping through it or having to do a lot of reference to it, which we'll get into more later. All right, and what if we wanted to convert that back to a data frame? Well, 3 hoops reconvert equals as.data.frame hoops 18. Or wait, 3 hoops stats, and we get 3 hoops reconvert. It's back to a data frame. See, that's when you want to use head right there. See how it went all the way down? That's why you'd want to do head. Head, 3 hoops reconvert. Now we only get the first 6, data frame. What if we wanted to convert the first column in 3 hoop stats? So head, 3 hoop stats. What if we wanted to convert the OE one into a vector? Well, as.vector, 3 hoops stats 1, and now it's a vector. The first column, OE, is now a vector. So as.vector, as.matrix, as.data.frame. And you're probably wondering, how do I create a data frame from scratch like with the matrix command? Well, it's pretty simple. So let's do this. Our data frame equals, and when I say equals, I mean arrow hyphen, equals data.frame, and then let's do 3 hoops stats, and then strings as factors equals false. Every time I create a data frame like this, I always make strings as factors false. Trust me on this one, otherwise it'll automatically make every string in there a factor, and it'll be a pain to work with, so just get in the habit of doing that. So when I do this, our data frame, well, now we head our data frame. Well, it's pretty much like we did as.data.frame, only we created it from scratch, and it used the 3 hoop stats matrix as our data frame. And so if I wanted to add a 4th column to our data frame 4, even though it's 3, you just do this, and then a string, and now we do head our data frame. Well, now there's a column called v4 with string in there because we added a 4th column, and then we can rename that column. Our call names our data frame 4 equals 4th column. And then when we do head our data frame, now it's called 4th column. Bingo. Now, what I did right here, add a new column on there. You can only do it with data frames. You cannot do it with the matrix. So 3 hoops stats, right? Head 3 hoops stats. Well, what if I did 3 hoops stats, a new 4th column equals 0? What's going to happen? It's going to say out of bounds, because a matrix is fixed in terms of columns and rows, not a data frame though. You can add new columns and rows for data frames, but not with matrices. Matrices, whatever, who cares, right? And whenever you're trying to get help on something, if you don't know how a command works, just try question mark and let's say matrix. And it'll pull up a help file about how the matrix function works. Or if I did question mark square root, it'll pull up a help file about that. That's how you can get information about a certain function that you might not know how it works. But that right there is pretty much base R. So that wraps up this first video. That's probably going to be the longest video of this series because it's teaching all the base concepts of R, how to use math, how to use vectors and matrices and data frames and all that. But learn what I just taught you. Master that, get it down, learn it like the back of your hand, so when we're going forward, it's not going to be as foreign to you as to what we're going to do, because that's going to be the foundation of every video in the series going forward. Now, the next video in the series, we're going to talk about operators, if-else statements, for loops, and while loops, and all that type of stuff. Stay tuned for many more. I don't know how regularly I'll be able to get these videos up, but I'll be working on it. I want to get this series out there. I don't want to leave you guys hanging, so just stay tuned. These upcoming videos in the series, they will come. Anyway, until next time, this is Sports Betting Truth, signing off.